Howdy, AP PreCal. We are back at it. So in a spirit of full disclosure, the first two topics of the AP PreCal curriculum, they kind of weave together in a weird way, and so we had to break it apart in such a way that made sense to us. So we kind of pulled sort of from part 1.2 and then pulled from 1.1 and kind of mixed it all together. Y'all don't really need to know that, but that's why they're kind of mixed in. So what I want to point out to you, this is a topic that I haven't really taught this way before. So this is kind of new to the AP world. So what I did is I want us to find the average rate of change between, well, this point and this point. So what would be the slope of that secant line? So I have a negative, I'm going to do slope. So negative 2 minus 3 is negative 5. 0 minus a negative 2 is, what did I just say? Negative 5 over 0 minus negative 2 is positive 2. I'm going to write that as a decimal so that you can see something and, as we keep going. From B to C, I'm going to find the slope between those two. Negative 5 minus a negative 2 is now a negative 3 over 2 minus, those are 2 units apart. Okay, so that's a negative 1.5. Where am I? C to D. Okay, so negative 6 minus a negative 5 is a, oh, I'm going to sneeze. Oh, hang on. So sorry. I'm not going to edit that out. You are stuck with the real me. Okay, so this is negative 0.5. And then from D to E, now I've got a positive slope going this way. So negative 5 minus a negative 6 makes this a positive 1 over 2. I kind of did this on purpose where I spaced them out by 2s, but it doesn't have to be, so this is a positive 0.5. From E to F, I have negative 2 minus a negative 5, makes that a positive 3 halves, so positive 1.5. F to G, so 3 minus a negative 2, that's 5. 10 minus 8 is 2, so this is 5 halves, so 2.5. G to H, 10 minus 3 is 7. 12 minus 10 is 2. That's a 7 over 2, which is equal to 3.5. Okay, now here's the part that was new to me when I went to my AP training. And that is they want us to describe the concavity of the graph based on what's happening with the average rate of change. So notice on this one, what we used to say always in the past was concave up like a cup or concave down like a frown. Which is still true, but what they want you to do when you explain what's happening here, the graph is concave up on the interval A to H because the average rate of change, the AROC, is, well, notice all of these numbers are getting bigger and bigger and bigger and bigger. Okay, so what we'll say is the graph is concave up on the interval A to H because the AROC, the average rate of change, is increasing. When that average rate of change, notice we're going from a negative 2.5 to a negative, you'd rather owe me $1.50 than owe me $2.50. Okay, so you have a bigger, your value is bigger when you owe me less. Does that make sense? And well, 3.5 is obviously bigger than 2.5. These other ones here, how did that work? I can find the slope. What is this? Negative 2 minus negative 12, so that's a positive 10. And I think those are 10 over 2 is 5. 4 minus a negative 2 is a 6. Divided by 2 is going to be 3. Man, y'all, I think I need glasses and I'm in a state of denial. 6 minus 4 is 2. Divided by 2 is going to be 1. And then we start going negative, so I think it's negative 1, negative 3, negative 5, negative 7. You can go back and double check to make sure that I'm right. But on this one, we are now concave down like a frown. This is concave down, but what they're going to want us to talk about is that that's because the average rate of change, well, these numbers are getting smaller. These numbers are decreasing. Okay, this is a new concept for me, and I've definitely seen some problems they're going to make me struggle. I have to wrap my head around. Okay, so this I expect to be a review for you. The values are increasing. As the x value is getting bigger, then the y value is also getting bigger. Okay, so here, if the if the x value, a is less than b, if the a value, a is less than b, so we're moving kind of in this direction, then f of a is bigger than f of b. So the y values are doing the opposite there. They're decreasing. Anyway, okay, the rate of change is increasing when it's concave up. The rate of change is decreasing when it's concave down. Do I want to work this? Oh, sure. Okay, it's increasing, right? So it'll be increasing from -2 to 0. So we have argued every year about, do we use the hard brackets or the soft brackets? Do we use the parentheses or the bracket? What they told me in my AP training was that you can always use soft brackets. You can't always use hard brackets. But they also said that in AP they would take either one. So if there are times, so on this one, I am of the opinion that when it's turning right here, it's not increasing or decreasing. But if you wrote the hard bracket, AP would be okay with that, if that makes sense. So it's increasing from -2 to 0, then it's decreasing. So it was decreasing, increasing, decreasing, decreasing. Now we're going to increase from 4 to 7. So we'd say union 4 to 7. Whereas it decreasing, we just said -4 to -2, and then it's decreasing from 0 to 2. Union. And then it's also decreasing. You know what? You could go ahead and change this. You could say it's decreasing this whole way. Now something happens, that's now a 4. Something happens here, but it's still decreasing all along that. If you broke it into 2 pieces, would I take off? I don't think so. I think I'd give you full credit. Where is it concave up? Well, that's where, notice my average rate of change between, like, I could pick a random point. It's real steep but negative, so then as it gets less steep but still negative, it's actually the value of it is getting bigger. Here the slope would be close to 0, and now it's getting positive and more positive. So we can see that it's concave up as that average rate of change is increasing, and that's going to be from 2 to 7. Where is it concave down? Well, notice how steep this is, and it's getting less steep, and then it's at 0, and then it becomes, so it's decreasing. It's now a negative slope. So it's concave down from -2 to +2. Okay, both increasing and concave down. So concave down and increasing is going to go from here to here. Over here, so what do we say? Increasing, so -2 to 0. If I look at, okay, it's increasing over here, but over here it's concave up. So that's no good. Both decreasing and concave up. So it's decreasing here, but it was concave down. It's decreasing here, and it's concave up. So this we would call an inflection point where it's changing concavity. What did I just say? So from 2 to 4. This one, I made an answer key already, and then I've slept since then, so I forgot exactly what I did. But there's multiple correct answers. Would you like to see me think through it? Oh, this is already a long video. Let me make a one last video.